Hey guys, Mr. Lloyd here, going to work with you on page 2 of 3 for Wednesday, April 15th. So this is the page that says 6-3 and homework at the top. And let's get right into it. The very first problem, your answers for problem 1 and 2 are going to vary significantly. So don't feel like if you're looking at this to check your work, please don't feel like your answers have to be the same, because this is a problem that asks you to visualize your own prism and then just sketch the base on the paper provided here. So my base here, I just chose 4x2. And then when it says choose a fractional length here, so remember this base is representing a rectangular prism or a box. So you can sort of imagine that coming out of the paper is the height. And so it says choose a fractional length for the height. So a fractional length is just a height represented by a fraction. I just chose 1/3. And so then my equation here, my length is 4, my width is 2, and I already set my height. So then my equation for volume is simply 4 times 2 times 1/3. So that gets us through problem 1. Problem 2, this one might be a little bit tricky for you. So if you're struggling with it, bear with me. I'll do my best to explain it. It's something that's very hard to explain without a physical cube in my hand. So unfortunately, with the remote learning situation, we're just going to have to do our best here. But don't beat yourself up too much on this one if you're not sure what it means. What it means is you have to think about if we had cubes, how many cubes would we have? Well, the cube has to have at its largest length. It can be no larger than the smallest height or the smallest measurement. And so in this case, my edge length of each cube is 1/3. Now, if you chose a different fractional height, your edge length will be a different length. I just chose 1/3. So the length, if each cube is 1/3 of a centimeter, then to get 4 centimeters, I'd need 12 cubes for my length. And if each cube was 1/3 of a centimeter, to complete 2 centimeters, it would be 6 cubes. And I don't know why I wrote 8 there. That was a mistake. That should be 6, because each one of these is 1/3. So you can see even I goofed that up. So don't sweat it. We're going to let number 2 go. Hopefully that explanation helps a little, but we're going to let it go. I'm not going to be grading that one. Calculate the volume of the prism you visualize. So I just use this equation here and I solve it. My work is right here in the margin if you want to look at it. Finding the volumes for 4, 5, and 6. Let me show you my notebook paper I used to solve 4, 5, and 6. If you'll notice, they look very similar. I try to structure these so that they would look the same here. So problem number 4 first, I list my length, width, and height. I always remember that volume equals length times width times height. What you have to do on number 4 is convert these mixed numbers, 4.5 and 3.5, into improper fractions. And then we just multiply one step per line. I work down the page one step per line. We've been talking about that all year. And finally, I simplify my fraction to get 94.5. I'll just keep going on number 5. Same type of process. I list my measurements. I go ahead and carry out multiplication, and there I am at my final answer. Pretty straightforward on number 5. Number 6, really similar as well. I list my length, my width, and my height. I multiply length times width times height to find volume. And, excuse me, here I'm just doing the same process. I do have to convert, just like I did on number 4, you have to convert mixed numbers to improper fractions. And so I do that, and if you'll notice, I just do one multiplication step per line. So even though this line has 2 multiplications, I just do the first one and save the second one for the next line. Okay, so that's 4, 5, and 6. Finding volume, let's see, we have 7 and 8.